In this video, I want to talk all about inequalities, what they are, how you can solve them, and some rules you should know. By the end of this video, you'll be able to recognize when to flip the sign, how to solve linear inequalities, and how to solve nonlinear inequalities. So before we get started, I want to get down to the basics and show you some similarities and differences between inequalities and something you should already know by now. So hopefully you are familiar with this, an equation. An equation is a statement that is true or equal, indicated by this equal sign over here. Solving this should be relatively easy. Subtract 6 from both sides and divide both sides by 6. Once you isolate x, you're done. X is equal to 2 is your solution. But now relating this to an inequality, let's have the same exact numbers, but now instead of the equal sign, replace it with a less than sign. This inequality simply states that 18 is less than the linear 6x plus 6. Solving this inequality should be very similar to an equation, much like we did over here. You isolate for x by subtracting 6 from both sides, and divide 6 from both sides to isolate x. Comparing both solutions, the equation's solution states that 2 is the only number that will satisfy this. Nothing less and nothing more. But on the other hand, the inequality solution states that all values of x that are greater than 2 will satisfy the inequality. Numbers such as 3, 5, 1,000, or even 1,000,000 will satisfy this inequality. We've just seen the less than sign, but there are also 3 more signs out there that you can use for inequalities. This over here to the left is the greater than sign, and this just says that some number x is greater than some number y. And over here is, of course, the less than sign, which you've seen last example. And over here to the bottom left is the less than or equal to sign. And this function is right in the name. It can also be equal to it as well. And over here is the greater than or equal to sign. A good way for me to remember which sign goes with what is to remember that Pac-Man's mouth is eating the larger number. So if you can replace the less than or greater than sign with Pac-Man, his mouth is facing the larger number. So here y is larger than x or greater than x. The important difference for inequalities is that there are some rules you must follow when working with them. There will be some cases where you'll have to flip the inequality sign. You must flip it in the sense that it goes in the opposite direction, meaning that a greater than sign will become a less than sign, or vice versa. Whenever you're manipulating inequalities with negative numbers, you have to watch out, because if you divide or multiply by a negative number, you must flip the inequality sign. So for example, on your left, if you have this nonlinear inequality, you would obviously start by dividing both sides by -2. But since you were dividing by a negative number, you must flip the inequality sign to continue. So less than or equal to sign will become a greater than or equal to sign. Now, on this example on the right, you'd start by multiplying by -4. But you have to recognize that since you're multiplying both sides by a negative number, you have to flip the sign like so. Now, it's always a good idea to dive deeper and fully understand why we must flip the direction of the sign instead of just blindly doing it. So let's take an inequality that we obviously know is true. 10 is greater than 6. Now if we multiply both sides by, let's say, a -1, you'd get -10 is greater than -6, which we know is a false statement. However, if we flip the sign, we can see that this equality is now true. -1, or be it any negative term, you must do this. This of course happens when you divide by a negative number as well. Try dividing by -1 instead yourself and see what happens. You'll find out that you yourself would get right at this line over here. You should know that those are not the only scenarios where you would flip the inequality sign. In the future, when you start studying rational inequalities, it is important to know that you cannot multiply by a variable term unless you know it's always positive or always negative. To illustrate this, let's bring out this rational inequality right here. Your first instinct might tell you to cross multiply, but you actually can't. This is because you do not know whether you need to flip the sign or not. Let's say x was negative 1. This term right here, underlined in blue, would be negative 3. Since you cross multiplied, you just multiplied by a negative number and would need to flip the sign. But since you do not know whether these four variable terms in this inequality are positive or negative, we do not know whether to flip the sign or not. It's because of this, we need to move all the terms to one side by subtracting, which you should know by now will not cause any problems. Now, keeping all of the rules you've just learned in mind, let's start putting them to use and solve some actual inequalities. We'll start off with a linear one. As said before, solving linear inequalities will be much like solving linear equations, in the sense that you're trying to isolate for x, or a variable. So if you are comfortable with equations, you'll be very comfortable with inequalities. The only thing is to remember those rules, and that we are asked for all values of the variable that we can substitute back into the inequality and get back a true statement. So our answer will, in most cases, be inequalities themselves. So starting off with this linear inequality, let's expand and distribute so we can get rid of the brackets and combine like terms. So distributing the 2 in and the 3 into the brackets, we can next quickly combine like terms just to make it easier for us to read. So the 2 and the 4 on the left side will be a 6. And now, isolating for x, we can subtract 6 from both sides and subtract 12x from both sides. And we'll have negative 14x is less than or equal to negative 12. But again, you have to remember on the very important rules for inequalities. Since you are going to be dividing by negative 14 to isolate for x, you have to flip the inequality sign to continue. So divide negative 14 both sides, and reducing will get as our answer x is greater than or equal to 6 over 7. And this right here is our answer. And as you can see, linear inequalities are very similar to regular equations. Now let's move on to some nonlinear inequalities, which will be slightly trickier. Let's say we want to solve the inequality x squared minus 10 is greater than 3x. We want to figure out all of the values of x that, when plugged back into this inequality, will return a true inequality. So, starting off, if you remember near the beginning of the video, I said that solving inequalities are much like solving equations. This doesn't change for nonlinear or polynomial inequalities. So let's start off by subtracting 3x from both sides, just to get it in a form that we are used to. It is still greater than 0, as that subtracting the same quantity from both sides won't change the inequality. Hopefully you are far enough in your math career that you're familiar with quadratics and the many ways that how you can factor them. So continuing with factoring, we want to find two numbers that, when multiplied, is negative 10, and when added together is negative 3. Hopefully you're thinking of negative 5 and positive 2. When you multiply them together, they are negative 10, and when you add them up, they equal to negative 3. So we can rewrite this as x minus 5 times x plus 2. So now what? Well, we have a quadratic equation in factored form. Factored form easily tells us the roots of the quadratic. So let's actually graph this and actually understand what this inequality is really asking for. If you remember, the x values that, when plugged into these brackets, makes this equal to 0 would be a root or x-intercept for our graph. So for example, plugging in 5 into this bracket would make this equal to 0, and plugging in -2 would also make this to 0. So those are our roots. So let's plot them. -2 and +5. Before we finish sketching, we need to know whether this parabola opens up or downwards. Since there's no negative out in front of the brackets, this parabola opens upwards. So let's finish our graph. It's asking us, this inequality, what x values is this graph, x minus 5 times x plus 2, is greater than 0? Well, we obviously know that a function's output is 0 at the x-axis. So we can view this as what x values is the graph above the x-axis, since the x-axis is our 0 mark. Parabolas keep going towards infinity, as you already know. So our answer would be x is in the intervals negative infinity to -2 and +5 to infinity. Notice that we do not include -2 and 5 since it's only asking us for greater than. If it was greater than or equals, then we would include these values.